Okay, so thank you for inviting us to present to her project. And we are Ursula and Pascal. I'm a light designer and Pascal is a PD programmer. And we are both music, sound and video artists. So, and we developing this project with Marek, Nico, and Kevin, but he's in Paris. So it's about, the first part, yes, it's about topography, because this project is about mesh network able to transport sound in a defined landscape. We are interested to work on location and yes, and grafting on it a technical device and create by this way discrete disturbances. And we use its characteristic and play with her environment, and because the aim is to integrate new particularities, new incongruities inside this soundscape. And for example, amplify some details or some details hidden in it, or exaggerating its own properties. It's like create sound straps. And we'd like to succeed to build virtual bridges between 2 or 3 many places. And of course, yes, we'd like to do that in many places and in different environment to find different sounds, of course. And yes, so it's a work about acoustic. À toi.
Alors, then, as you can now understand, the principle is to add a microphone and speakers.
Raise your voice.
Sorry?
Speak louder.
Okay. As you can now understand, the principle is to add a microphone and speakers. It put our output in every node to capture some sonic properties. So the main work is for us is of course an acoustic work. As you can see on this picture. We have to care to finding the good way to capture sound, and we have to choose the more appropriate sound capture techniques. We can use, for instance, contact microphone like that. Like this example. This one. To capture vibration in materials. Vibration on a wall, a window, or a metallic cable, and so on. Or electrate microphone, like this one. For other sound.
Yes,
or create a special setup, for example, with a hydrophone.
Hydrophone, yes.
To play with water in a pool. In a small river, if there is one. We have made little maps that explain such installation in the TMP lab and its environment. And in this example, on a corner of the wall, some captation of squeals and opened a door, an airstream at the bottom of the steps, the sound of a vehicle passing by the street near the place is transmitted to another mesh point, not very far from it, provoking a gap between the real sound and the transmit sound. In this case, sounds are mixed with others. The sound at the bottom of the door with the squeals and the sum of the vehicle and so on. In the next example, or the next pictures, micro contact is hanging on the metallic fence. The wind in the tree, in bushes provoke some kind of vibration transmit by the metallic fence toward a contact microphone. In the same time, we can hear some conversation, for example, some slide chair on the concrete floor, some dishes in the ceramic sink. All sounds are immersed in a very slight sonic distortion provoked by the sound compression.
Okay. So, yes, it's about real time, and in this project, the more interesting is to use all the evolutions of this landscape in different moments during the night, for example, and during the day. And the goal is not to transmit samples that we know before, but to play in real time and with all the action in present. And yes, because we would like to set up an installation and could be surprised by the evolution. And maybe the most important point and the most interesting is for us the last step of this project development, and it's to include mobile points inside the network. And for example, we can imagine a worker in the landscape bring a Phonera box, and he can influence the nearest node and could suddenly transform all the configuration. And that is to say, the worker is able to change the path of the sound and inside the network and change all the topology. And but we are not exactly at this step, and we succeed to send a sound in 8 notes, but it's the second part. And so I think it's okay for us, and this short presentation. Thanks. Non, ça suffit, c'est pas grave.
Ouais.
Great. Great maker.
So, just want to start myself.
You start. Should we start? Should I start?
Shot start and then I'll go to history.
So, hello. Now that you have all understood the high-level goals of this project, we're going to dive into the technical implementation. So, Nico.
So I will give a bit of history of the project. It started as a crazy idea during hacking sessions at the TMP lab in Paris, involving some beer and some late hours, and lots of people from different backgrounds. We did a first experiment at the CNAM in Paris in 2010. There was a small testbed with 8 nodes in ad hoc mode. Those nodes were Phonera 2. I have some here. This one with the USB stick, USB port, so we plugged the USB sticks, audio sticks, and the hub and some USB speaker, or speaker of all sorts, like this one, this funny one, and this one also. We were streaming MP3 from VLC to all the 8 nodes in at the same time on multicast. I still have a setup plugged here, and it's still working apparently. I'm streaming from my laptop to the Phonera here with these 2 USB speakers. And I can stop it. So it works. What we did, in fact, inside it was I was just using the FFmpeg command line daemon with a really streamed version of FFmpeg using just MP3 encoding and decoding and outputting to the OSS sound card. There were several problems.
You want to show the video?
Oh yeah, we have also a video I can show you. If I find it. There won't be much sound. So we have this massive setup with the 8 nodes and all speakers all over the place. So different speakers, different phones. And we were streaming some talks with a really low voice, and over the time each Phonera was desynchronizing from the others, so there were some interesting echo effects and weirdness. There were lots of problems with that kind of setup. I tested lots of different audio streaming solutions like Pulse Audio, GStreamer, and finally managed to have something which worked with FFmpeg. I also tested different codecs and formats, AAC, AC3, SPIX, lots of different things, and nothing really worked like we expected. So we decided it was time to cut something new. Basically, strip down multimedia audio daemon which should be able to record and play audio streams from the network and play it back on the sound card. It should record the remote control capabilities, so we can manage all nodes from a central location. And it should provide efficient and flexible sound distribution with some way to interactively change which node streams which audio stream, and all that with multicast. because 2011 is the year of multicast, so should do it with multicast.
Yeah, so maybe to understand the whole setup a little bit better, we have a given set of nodes. The nodes that have an R are just relay stations, so normal mesh nodes, mesh routers that just don't do anything. And A1 to A3 are audio sources or audio destinations that are deployed in the field somewhere. And we have a central controlling instance that is, we can imagine some kind of UI that wants to see all the nodes in the field and wants to say, wants to control these nodes. Say, this node should play that sound, or it should record sound, it should send it over there, and it should do this. So it's a kind of like a mixer, a big mixer on a mesh environment. So our multimedia daemon has a small message system that just says, I'm here, which is very similar to the hello packet or whatever. So every node that's running the multimedia daemon will just announce itself, so that our UI will say, okay, we have found this node, and it will offer some options like you can make this node play that sound, or stop playing the sound, or apply some effects.
Increase volume, decrease volume, add delay.
So it's a very basic system of gathering information about all the nodes that are in the field in an ad hoc manner. Yeah. And later, when the controller decides that a node should join a certain sound stream, it will send a command to, let's say in this example, A3, but it will just flood. We use a multicast group, and all A nodes, so all multimedia nodes join this multicast group and will receive the messages and pick out the messages for them, the commands. And we can imagine in this case, the controller decides A3 should join a group, and then A3 will join the group and will listen to the sound stream that either is coming from the controller himself, or maybe A2 records some audio and A3 is playing the audio. So we have two messages sending forth and back to remotely control the audio daemons that are running on the various nodes. Questions so far?
Did you make the link with the...
Yeah?
You were using multicast loop in there?
No, we don't. This is not a mesh system. We don't care. We are the application. We expect that there is a mesh software that handles multicast routing, and we just use multicast. We expect that the mesh layer is doing whatever is necessary. Yes?
The encoding is not done on the devices. You have special recording devices creating the signal, encoding from analog audio to whatever coding.
Well, we come to this later. Maybe we skip this question for now. We come back to this in a second, I think.
So the basic architecture right now is we have a way to define multiple audio sources. Either it comes from the network, it comes from the sound card, or even from a local file, or even the view random if you want white noise. We have multiple audio destinations. You can use the network to send sound frames. You can use the sound card to play back the sounds, or you can even record the file, audio into a file. Audio sources and audio destinations can be altered with some kind of filtering system, so you can add effects or increase, frequencies or whatever you want to do. Delay.
Maybe listening to two sound streams, mixing them together,
mixing sound.
All kind of effects that audio artists like to.
Cool effects.
Cool effects.
So basically, you have the sounds which enter the filters and then gets altered in some way and then throw to the destinations. And you can have as many sources, filters, and destinations as you can fit in such small boxes. The goals right now are to have a network, so you can record sounds at some location and play them back to somewhere else. It would be great if it could scale to an arbitrary number of nodes, a massive mesh network with hundreds of nodes and hundreds of microphones and speakers.
And streams, multimedia streams.
And lots of multicast streams. It would be also nice to control all the nodes from a central location, so you have this cool UI and you can click and just pushes changes to the network, and every node reconfigure itself. And it could also be nice to apply some effects depending on how the nodes interact with each other, or depending on the mesh network topology or signal strength, or I don't know, traffic, whatever. Having some way of applying effects on the sound frames in the filtering layer that also gather some information from the network itself. Where we are now. We started the development.
But the prototype is working.
Yeah. Early stages of development, but like we said, in the software industry, we are almost 80% complete. We are still not sure of anything. Not sure which codecs, either MP3 or whatever, or we don't know either which formats to use, because we need some timing embedded in the frames somehow, so each nodes are synchronized on the network. And these devices have limited capabilities. They don't have any floating point units, so we have to find something that can, some codecs or transport or formats that can be handled by this device, especially for encoding and decoding audio. We are still not sure how many streams we can put on the mesh network, and we are not sure these devices are well suited for what we are wanting to do. But
always looking
cheap.
for better.
Yeah.
Always
They're
looking
cheap.
for better hardware.
Then we know they're somehow almost mocking. Anything you want to add?
No, I think.
So, conclusion. This is a groundbreaking framework. Almost everything is done. It's available on GitHub already. And we need more people, audio and networking engineers, to jump in and help us. That's all.
I'd like to stress the audio point, because we both are more, we are embedded and network specialists, and there are so many codecs and encoders and decoders and libraries over libraries and multimedia daemons and whatnot. We have played with most of them, but now we want to put audio on the sound card, so we use OSS as a sound system, and there are also many options that some of them we even don't know what they do. So it'd be great if somebody says, I know audio, I understand all these codecs and all this stuff that's out there, and I know what you need. Well, then feel free to contact us. We will offer a free beer in exchange. If it's working afterwards, there will be a second beer. So the advice is one beer, and if it's working, then second beer.
There is somebody opting for beer.
Yeah, we have some.
We had similar ideas already, and one of our guys is doing on the. We had like the landscapes, soundscapes, so that we make sounds, but not process it. So this part is we just wanted to collect all sounds. So we researched a little bit. So I am giving you one information, and you will give me back. We are searching for good USB microphones. Do you know any of which are cheap but not on just sound?
You need decent lining, which is around 25 euros. Cheaper you won't get like such everything.
So we found some of 5 euros, but probably this one will not.
No,
I don't know how good they are.
They're mono and it's just pure baked in, so you won't get decent sound ever out of them.
Can you say the name?
For the cheap ones, you find them on eBay, just simple USB sound cards.
I would like a good sound. That's the question.
So this is I make or I like for 25 to 30 euros, not cheaper found anywhere.
Can you put somewhere links to that?
It's just generic, there is no name.
And I mean the codec. There's I don't know how it's pronounced, like C Foundation, the organization community is for Vorbis, and they're doing with the Kent codec now.
Yeah.
It is an alpha stage somewhere, but it promises exactly the things.
We didn't try it yet.
Yeah, but it promises exactly the things which are needed for the national program. This is what?
We tried coding already, and it's capable of encoding a file on the Fonera.
Yeah.
So the Fonera is capable enough of encoding.
Because it is meant for embedded systems, so it will be also without floating point operations. It is meant for such devices. It is low latency, so it will be also possible to use for voice or something like this. But it is not voice specific, but it is music sound specific, like general sound. So
that's what I read.
So it promises all the currently after stages. It is already doable, but they didn't fix the bitstream and so on. So it is not like there is still to leave open for themselves to fix things. So maybe you should try it out.
Yep.
Kent.
Kent?
C-E-L-T.
Yeah.
And in the tried codec, I don't see OGG.
And the problem is floating point.
Floating point.
No, I know there is.
There is stakeholder.
Okay.
Vorbis deck.
I think if you want to keep a CPU load low and you want to get to as close as possible to real time, you want to do that, right?
Yeah.
For example, a 4-bit ADPCM is a simple codec which is fast. It significantly reduces the size.
It's not suitable for stereo.
Why not? It's just you have to encode 2 channels.
We can do that. Multiple audio sources.
Do you actually have stereo input?
Yeah, most of the microphones.
The USB sound cards usually have mono input.
Yeah, but do you actually have stereo microphones and stereo vibration sensors, or are they all mono? Is stereo even a subject?
No. It's version 2.
So which recording equipment do you use?
What?
Which USB devices do you use?
We didn't do any recording yet. Just playing back some streams.
Only 80%.
Yeah.
The recording is easy.
Yeah.
So there are also some. There is one other codec I tried. It is the WBMv4 or something like this. And it is lossless in original, but it supports also lossy compression, and it is also has a version for integer only. And I managed to get that also on Fonera running, but in real time, but it is quality is not good. So I'm looking for Kent.
Yeah.
So this is information I can offer.
Thank you.
Thanks. Yeah?
Just want to know what kind of, what are your like funding sources? It seems like a pretty expensive.
No, not so much.
What is the expensive part?
Buying all these equipment.
This one cost like 12 euros.
Yeah. It's just out of pocket.
The hubs, USB hubs were 5 euros.
Okay.
No, it was not so much expensive.
And this is just speakers that connect to USB?
Yeah.
That's excellent. The sound card is included.
Yeah.
Yeah.
That's good.
And they're funny. They have different colors. We have pink ones over there. And some strange life forms.
On the Chinese market, you get every shape and color.
It even makes light here. Any other questions? So do we have? What?
How did you choose your username on GitHub?
You guess.
I think it's very, very complicated to achieve something in real time. So if you want to have the output of different speakers coming out synchronized without any delay, I think it's a hellish job to achieve that.
Version 4 then. Version 4.
WBMv4.
Yeah.
It's very easy to do that in analog technology. If you have different channels and you just use the little computers that you have to control transmitters and receivers. So you can do it analog and control it from the digital world. But of course, it's a real challenge to do it in digital. If you master it, chapeau. Chapeau.
Okay, then thank you for your attention and enjoy the break for the next talk. The next talk starts.